All right, so let's carry on with our integral skills. So first thing, looking at C here, is that we've got a quotient. So it might kind of stump you at first, right? Maybe you're thinking like the quotient rule or something like that, but we're going backwards, so that doesn't make any sense either. We haven't really learned how to do this yet, but we're good now at finding the integral of individual terms, right? So let's just rewrite this as individual terms. So this would be the same thing as, so the integral from 1 to 4, and then this would be 2x squared over x squared minus x over x squared, and then plus 4 over x squared dx. Okay, that's going to work out better. We can take the integral of each of these pieces. So I'll simplify this again. So this is from 1 to 4. Oh, sorry, that should have been x squared. Maybe you guys noticed that. All right, so those cancel. So we get, so that's 2 minus, and then I'm going to leave this as 1 over x. And I just know to do that because, well, we're going to see in a minute the antiderivative of 1 over x is the natural log of x, right? So that's a nice way to leave it. And then for this one, I'm going to rewrite this as just 4 to the power, or 4x to the power of negative 2 dx. Okay. So then let's go back through and take the antiderivative of each term. So this becomes 2x minus, and as I said before, the natural log of x. And it's actually the natural log of the absolute value of x, but I don't really have to worry about that because I'm just throwing in 1 and 4, right? When I go through it, which is definitely above 0. Okay. And then this becomes, so plus 4x to the negative 1, so adding 1, and then that would be over negative 1. So why don't we just call this minus 1 right now? Okay. So that was the antiderivative, right? And typically you'd say plus c, but we're going from 1 to 4, so we can just kind of write this, right? It goes from 1 to 4. So now we're just going to do that for both. So this would be, use square brackets, 2 times 4 minus the natural log of 4 minus, and then this would be 4 over 4, just x to the negative 1 is over x, right? Is all I did there. Minus, and then 2 times, and then it will be the 1 that we're putting in. So 2 times 1 minus the natural log of 1 minus 4 over 1. All right, so we're running out of room, so I'm going to carry on up here. So now we have, so 8. So it was 8 minus 1, so 7 minus the natural log of 4 minus, and then it'd be negative natural log of 1 and then minus 2. Just collecting those constant terms. Okay, so then 7, so minus negative 2, that would be like plus 2, so 9. And then we've still got negative or minus the natural log of 4 plus the natural log of 1. All right, so we're able to collect our natural logs or combine them. So this would be the same thing as 9 plus, and then it'd be the natural log of, and then remember, if it's like minus with our natural log, it's in the denominator, and if it's plus, it's in the numerator. So that'd be the same thing there. That might have been easier, like if you can picture that as, natural log of 1 minus the natural log of 4, right? And then that's a bit more, 1 over 4 with your log laws. All right. So then, yeah, so that's it. All right, next one. All right, so from your formula sheet, so let's go back up to our common integrals. We can see right here secant x tan x. So the integral of that is just secant x. All right, so that's going to really apply to this one. Even though we have 2x and 2x, you can think of that as like, theta and theta. So this would be the same thing as, so we can say this is equal to secant 2x. But then remember, with our antiderivatives, it would be like times 1 over k, right? And the k value was our 2. So it's like 1 over 2 or just secant over 2. All right, so it's that from 0 to pi over 6. All right, so that's equal to, so pi over 6 will go in first, so it's secant 2 times pi over 6 over 2. And then minus secant 2 times 0 over 2. All right, so this is equal to, all right, so this is really secant, so this is 2 over 6, so that'd be the same as just pi over 3. And cos, if you think, so cos of pi over 3, right, so pi over 3 would be like up here, right? So cos of pi over 3 is at a half. Okay, so 1 over cos of a half of pi over 3, so this is like 1 over a half, right? Which is just equal to 2. So we've got the numerator here is really just 2. So we've got 2 over 2, which is 1. Okay, minus. And then we've got secant of 0, so that's like 1 over cos of 0 degrees. And cos of 0 degrees is 1. So this is, so our numerator here is really 1, so it's 1 over 2. All right, so this all comes out as 1 over 2.